In this last video on area and the definite integral, we're going to be looking at two examples that are a little bit more complicated. So let's first look in general. We've got two functions here, f and g. They intersect in 3 points, a, b, and c. And let's say we want to find the combined area that is enclosed by these functions, bounded by these functions. So as you can see, if I look at the area between a and b, if I want that area, the function f is on top and g is at the bottom. So that area will be f of x minus g of x. While the area between b and c, now g of x is on top. So I have to add to that the area from b to c, now g of x is on top. So if g of x minus f of x. So that is why I say it's very important that you sketch the graphs. You need to know what the picture looks like. You cannot just set up an integral from a to b of f minus g or g minus f or something like that. You need to know what the picture looks like. So let's take a look at two examples. Firstly, find the area of the region bounded by this parabola, x equal to minus 3, x equal to 4, and the x-axis. All right, so if I had to factorize this, I've got x minus 3, x plus 2, x plus 3, x minus 2. There we go. So if we had to sketch that, minus 3 and 2. Now it doesn't really matter to me where the turning point is. Even the y-intercept doesn't matter. But what I need to know is, what am I working with here? I want the region bounded by this function, x equal to minus 3, so over here, so that's good, and x equal to 4, over here. So if I see between minus 3 and 2, my function is below the x-axis. Then between 2 and 4, it's above the x-axis. So to set up that integral, that's the most important part. The integration you can do by now, but setting up is the problem. So we go from minus 3 to 2. What function's at the top? Well, it's actually 0. 0 minus my function, x squared plus x minus 6. And add to that the integral from 2 to 4. Now what is on top? Well, my parabola is on top. X squared plus x minus 6. And you can say minus 0, but that would not make a difference. So we have to break that area up into two parts, else we're not going to get it right. So that is, I've got minus x squared, so it's minus a third x cubed. Minus x, so it's minus a half x squared, plus 6, so it's plus 6x. Between 2 and minus 3, plus the second one, I've got a third x cubed, plus a half x squared, minus 6x, between 4 and 2. Now, both of these brackets should give you positive numbers if you've done it correctly. So they should give you positive numbers. The numbers are, with a bit of work with your calculator, 125 over 6 plus 38 over 3. And if I add them together, I get 67 over 2. You can check that. I do sometimes make calculator errors because I'm not so good on my calculator. But there we go. That's what you should get. And again, it's unit square, whatever the unit is. But that's not my concern at the moment. All right, let's look at another one. Find the area of the region bounded by y equal to x squared minus 4x and minus, or region bounded by just those two functions. All right, so now let's see what we're doing. If I just sketch that, that is x minus 4, and this is minus x squared plus 6. Let's see what I need. Minus x squared plus 6 looks like this. So this is 6. I do not have my x-intercepts. It's minus root 6 and root 6. Let's see if we need them. X squared minus 4x cuts at 0 and cuts at 4. So we just need to check, is 4 bigger than the square root of 6? Yes, so it's on this side. So this graph goes like this. I want the region bounded by the 2, so this is the region I want. So that's nice. It's from there to there. Which function is on top? It's minus x squared plus 6 minus the function x squared minus 4x. Remember those brackets, dx. But now where do I start and where do I end? I can't easily read off these values, so we have to do a bit more work. What do we need to do? We need to see where these two graphs intersect, so we set them equal to each other. So x squared minus 4x, when is that equal to minus x squared plus 6? Well, that's when 2x squared minus 4x minus 6 is 0. Now, when you factorize that, I'm going to divide all the way through by 2, so I've got x squared minus 2x minus 3 equal to 0. Factorize that, and I've got a 3 and a 1. It's a minus 3 plus 1. So it intersects where x is equal to 3 and x equal to minus 1. And that looks reasonable if I look at my sketch. So it's my integral from minus 1 to 3. So that's what I'm looking at. Now, before I can start integrating, let's just tidy up what's going on inside there. That's minus x squared, so I've got minus 2x squared, plus 4x plus 6 dx. That's what we've got. Now we can find the antiderivative. That's minus 2 over 3x cubed plus 4 over 2, so 2x squared plus 6x between 3 and minus 1. And yet again, do some calculator work. And you should get to 64 over 3. You can just check that with your calculator, but that's how you do it. So that's area and the definite integral. Takes a bit of work, but that's how we get there.